Hi everyone. In this demo, I'm going to show an example of R code that uses the caladaptR package to import some downscaled climate data from caladapt directly into R using the API, and then we're going to plot it. So here I've got RStudio open with a demo script that will be linked in the description if you'd like to try it out. The first command in the script is simply installing the package from GitHub. I already have the package installed on this machine, so the line is commented out. But if you haven't installed the package, that's step number 1, and there's additional information on that on the website. Next, I'm going to load the package into memory with the library function, which is standard practice. And at this point, I can now use the functions in the package after I've got it loaded. You may remember the first thing you do when you're working with the caladaptR package is to create an API request. So the next few lines of code that I'm going to highlight and then run by pressing Control-Enter are creating an API request, which I'm saving into a variable called Fresno_CAP. And if you look closely, this is simply a series of functions that are being strung together with these pipe characters at the end of each line. And each one of these functions provides a piece of the information for the API request. So the first function I'm using here, and the order doesn't really matter, but I'm using a function to provide the location of this request, and I'm specifically using a function that allows me to provide a point location by specifying the coordinates. There are other functions you can use if you want to specify the location maybe as a spatial R object that you've got loaded in memory, for example, a point or polygon simple feature data frame, or if you want to use one of the built-in area of interest presets that are supported by the caladapt server, such as watersheds, county boundaries, and so forth. The next function here is specifying the climate variable that I'm interested in. Here I'm asking for the minimum daily temperature. That's what Tasman stands for. Next, I'm telling it which of the global climate models I want it to send me. So I'm asking for modeled climate data. This is projected modeled climate data. And I'm providing the names of 4 of the 10 GCMs that are available through the API. These 4 are the priority models for California. Next, I'm providing a function which is specifying the emission scenarios. So it's pretty standard practice with climate data to look at a couple different emission scenarios. Next, I'm providing the temporal aggregation period. So I'm asking it to take those daily minimum temperatures and to average them by year, so I don't have to do that myself. And then finally, I'm using a function that specifies the start and the end date. And I'm using a function CA years, which allows me to specify the start and ending dates by year. So I've run those, so now I have a API request object. I can plot it with a plot function, and what that does is throws up a little interactive map, which just allows you to verify that you've entered the location correctly. So now we're ready to fetch some data. So I'm going to take that API request object and feed it into a function called CA_getVals_TBL. And if I run that, you'll see at the bottom, it's actually communicating with the caladapt server. It goes very quick. And it has sent the data back as a data frame or tibble. I can look at the results of that. I've saved them into an object called Fresno_TBL. If I run that, I can see what it looks like. And basically, it's a tibble or data frame with 8 columns, 640 rows. The first column is the ID value of the location. In this case, I only provided 1 location, so that's going to be the same all the way down. We have additional columns for the climate variable, the temporal aggregation period, GCM, so on and so forth, the date, and then at the end is going to be a column with the value of the climate variable, which again, it was temperature, and it's even telling me the units of those values, which in this case are Kelvin. So at this point, I'm basically done with caladaptR. I've retrieved some data, and I have it now as a data frame or tibble, but I will do a couple more things here. Usually you have to do a little bit of cleaning or manipulation before you can do a plot or analysis. So I'm going to load up the dplyr package and the units package. And I'm doing that so that I can use the mutate function from dplyr and the set units function from units to add another column to my table, which will have the temperature values in Fahrenheit. So if I look at the results of that, which I've saved into a new table called Fresno_temp_f_TBL, I can see that new column at the end of the table, which has the temperature values in Fahrenheit. If I wanted to make a plot of this, I can simply use the ggplot library. I'm going to highlight these lines and then click enter to run them. And you can see it's generated a plot. ggplot2 is a very popular plotting package, has lots and lots of plotting options. And the ggplot, that's the main plotting function. I'm simply telling it what table to use as the data source, how I want which columns do I want it to map onto the X and Y axes, to use a line symbology where the lines will be broken down into different series that will be colored by the unique values of the GCM column. Facet wrap is telling it to create separate plots for each unique value of the scenario column. So that gives us a plot for RCP 8.5 and a plot for RCP 4.5. And as you can see, the average daily temperature goes up faster under RCP 8.5 than RCP 4.5, which is well known. So that's it. In just a few lines of code, we've successfully imported some data from caladapt into R by creating an API request object, feeding that into a function that fetches data, doing a little enhancement to the data we got back, and then plotting it. So I hope that was useful, and thanks for watching.